So the last topic we discuss about the object modeling. And under the object modeling, we discuss couple of modeling tools which you can use to illustrate the development of an information system. So we start of capturing all the uh, required functional requirements with the use case diagrams. And based on the selected use case, you can draw a class diagram. And then with the class diagrams, we can go for sequence diagrams, which we can use to dynamic model of use cases. We can show what classes and how actually interaction happens. Right. And I think for up to this point, we discuss how the interaction happens with different classes, different, this line shows you the lifelines with focus box, which interact like how long it will be focused on a particular task, and also the interactions. And also sometimes the end of the object of this class also be represented. Now, the next thing that we have discussed is called state transition diagram, which indicates something else, like any object, you have some different states, and states may change from one place to another place. Like I told you about as a, when you come to the university as a first year, like as a fresher, like then you come to second year, third year, final year, and then once you get the degree, you will be alumni, right? So the state always changes. So that also needs to sometimes represent, and we want to document that. Now, in this example, what you see is a state transition diagram where you start looking at how different states of bank accounts. So this small circle indicates the beginning, and this circle indicates, it's actually double circles, which indicates the end of this state diagram. And it will start with opening an account. Like when you open up account, the account status will be new account. And let's, when you're going to start using it, it will become active account, like when you make your first deposit. Now, after that, there could be like different status, like sometimes, your activity, your account might be a frozen account due to various reasons. One could be is like non-usage of your account. If you do not perform any interaction with your bank account, like withdrawal or deposits, then they will say frozen. So sometimes in banking world, they use the term dormant, right? It become a dormant account. Like in this particular case, we say it's a frozen account. And then like, if you want to use it again, that you need to like, make a deposit or the withdrawal so that it will become again active. And then you can also have a closed account. Maybe bank can close the account. Maybe you have not use it for some time, or you don't maintain the minimum balance you need the account, so the bank can close the account, or the customer can close the account by him or herself, right? That also becomes closed account. So this diagram, as you have seen, like it can show you different states of a particular object, and sometimes this is very important that we capture all the information. The last thing that I would like to discuss is called activity diagram. This is sometimes also, you can see it as a kind of a flow chart, and you can show the action and events, right? So main point of activity diagram is you can show the order of the actions, and also you can identify any outcomes. Now, in this particular example, what you see is possible outcomes when you're accessing a ATM. Now, you can indicate these different activities. So your starting is represented here. So you normally, this activity starts with when you need some cash. So what happens? The first activity would be something like, okay, customer can insert the ATM card, and there'll be a validation process. The first thing is card should be accepted, and if the card is accepted, then customer has to enter the PIN. Then there could be situation whether the PIN is accepted. If the PIN is accepted, then customer can go to the next activity, which is you are going to request some cash. Now, there could be, in here, you can see two arrows, two outputs to indicate two directions or two different activities depend on whether you have sufficient fund in your account. Now, let's say you have sufficient fund in your account, which means, let's say, you are going to withdraw 100 and account you have 1,000. So, of course, you have a sufficient funds. So then ATM has to adjust the balance, the money in bank, and then you can get the money from the ATM. But let's say you get Tarusha, your okay. Make sure that you switch off. Tarusha, your mic. Okay. So we were discussing like what might happen, like when customer requests cash and when sufficient funds are available and when sufficient funds are not available. So depend on whether you have sufficient funds or not, you might get different, directions. So in this diagram, we'll show you if customer has sufficient funds, then ATM first has to adjust the balance and then you provide the cash. Now, if you do not have sufficient funds at the account, then ATM should notify the customer that there's not enough funds in the account, right? So you can see these are the different types of diagrams that you can actually use, especially when you are actually designing your information system. So these are like possible diagrams that you can use to capture various aspects of the design. And nowadays, it's sometimes not mandatory, or sometimes the development team is actually not focusing on the documenting everything, but it is always important when you have a mission critical system development, you document everything so that you are minimizing any errors in the future. And then the other one is the code maintainability, which means like somebody else can go through these modeling diagrams, and then they can keep on improving the system, right? So with that part, we will conclude what we have started. The topic that we have discussed is object modeling, right? My plan for the other session, the today's session, is we are going to go to the next step. So the next step is actually comes under system analysis, and we look at different development strategies, which we have already briefly discussed in the very first session, but we'll discuss in big details. Now, the idea of development strategies is, so once you have the design ready, the next step is you have to find how exactly you are going to develop the system. So we are going to briefly discuss how we are going to do this. Right now, when you look at development strategies, so how people actually used is very different. Now, for example, we can develop our own software, right? And even at the university, we have a small development staff. So which means any organization could have IT, department that they can develop software itself. Right now, The second choice, what we had earlier, is like you could have purchased the software as packages. Usually commonly available software there, like for example, thinking about university in term, we can actually develop, we can purchase some university. So for universities, people actually develop different software systems. For example, we have now learning management system, manage ourselves. And then we have like timetabling software. We have other financial, handling software is also available. So which means the second uh, method is like you could have actually purchased the software. So that was the second technique. Third, in early days, we used to hire consultants. We do nowadays as well. Sometimes when we don't have the expertise, we look for the consultants and then we get it done from them, especially when you want to develop something. Or maybe you can hire outside resources to perform the work, which means maybe, let's say we are going to develop a piece of software, and then what we have is we can get developers hire temporary, maybe let's say 1 year or 2 years time, and then we can get the work done. Now, if you look at what happens today with the involvement of technology, things have changed. Now the applications are developed as like application service providers are there. And also there are like many places offer web hosted software options. And then there are organizations which give us enterprise wide software solution. Now, the problem is, since when you have a lot more choices, you know what will happen, right? For anything, when you have more choices, you are in trouble, right? Like nowadays, for example, when you search information, we have internet, we have ChatGPT, we have other, AI tools. The problem is which one is to select might be a problem. So likewise, here also we have, the best development path is an important decision and also the crucial one. And also it's like complicated one compared to the setting today. So in this lesson, we are going to see some possible ways. We first look at some development strategies, and then later on we look at some financial tools which we can use to make that decision. So let's say you are going to have, as a IT guy, or in this particular case as a system analyst, your responsibility is to select which method best suited for you, whether you are going to develop the software or whether you are going to purchase the software, like what costs are involved and which one is the best choice for the organization. Right. Now, having said that, so let's look at some of the models available nowadays. So with the internet and also with the service providers models, there were many things came into the picture. The first one of the things that we can talk about is now the software is available as a service. We say software as a service. So in traditionally, we use the vendors used to develop and sell packages, and then we used to get some license. The license will give us the opportunity to use their software for a limited time. But now with the software as a service model, right? And the software is hosted is somewhere else, not in the within the organization. So what happens is we have to access the software through the internet. And the advantage we are getting by doing this is we don't need to focus on software maintenance tasks like updating or even purchasing hardware that you need to host the software. So you can actually reduce the burden of maintaining the software operating the software as well as operating the hardware, and also the support that can be actually taken from those who are actually hosting these services. Right. Now, here are like some example. We have different levels of hosting. Now, early days, what we used to have is all our systems over on premise, which means we had everything. That means we had our own hardware, we had our own servers, we have our own data, and we had the application. Now, with the internet as well as especially with the cloud computing, what has happened today is we are not actually bound to have everything in the same place. Now, for example, the first idea that we can talk about is infrastructure as a service, which means the hardware we can actually get through some service provider. Right? So, now, for example, Amazon and Google, they provide, a lot of information, lot of hardware options, right? So, which means now you don't have to really worry about, having everything in your place. That means depend on your requirement, you can get everything from somewhere else. Like, for example, Amazon Web Services, Google Cloud, Microsoft Azure, IBM Cloud, like these are like some of the examples where you can actually, purchase the servers, the processing power, the storage, and so on, right? So that's the first part of this. Now, then even for the development, that means the middleware, operating system, and even the runtime, you can purchase. So this is called platform as a service, or PaaS, right? No, so there are like different services are there, like Google App Engine is one, Red Hat OpenShift, Heroku, Apprenda is like some of the example for this. So what you are going to have is only the application and data. So you can have only application and data in your premise, and everything else you can actually purchase, which could you could save a lot of money as well. Or else you can actually have everything on cloud. This is what we call software as a service. Right? We have Dropbox, DocuSign, HubSpot, Jira, like these are some of the examples where we can see this, right? The information is there. So you don't really, focus on anything. You can focus on the operations, the work, your real work, right? So that's the advantage you might get when you have server-based models. Right. Now, let's move on. So when you focus on software as a service, there are many categories. Actually, I have taken this picture from the internet, which shows you like some examples. So you can use these for your productivity, and then you can have very specialized work or enterprise management. Now, for example, when you say productivity, you can focus on individual productivity like Microsoft Office, Google Workspace, even Adobe Creative Cloud. You can focus on team productivity like Smartsheet, Trello, Jira, Confluence. If you're working in the industry, these are the software that you have to interact, especially for your work assignment, right? And the communication, we can use Slack and Zoom. Workflows, we can automate most of our workflows using Zapier and Box. So these are like some software as a service for your productivity. And then when it comes to enterprise management, finance, SAP, Oracle, MyOP, like some software services are available. Human resource management, we have Workday and Bamboo. Procurement, and then supply chain, admin. So in all these, you can see, you can find software. These are like very popular ones. Then website development, Wix, e-commerce solution, Shopify, BigCommerce, customer relation management, Salesforce, Sendex, HubSpot. So you can see there are lots of software now available as a service. Right. Now you can see things have changed over the years and how these software solutions actually evolved. Now, this idea of software as a service, we can say it's the foundational idea behind what we call the centralized computing. So that means your entire business, right? And thousands of employees can run their software online, right? So that means the entire business are now operate on the internet. And you don't have to really worry about purchasing high-end servers, for example. We know, especially with the hardware products, the problem is every year, 3 years or so, you have to replace them. So which means this might be a wise decision when you look for the cost that you have to, spend on these hardware stuff. So all the processing, all the saving will be on the internet. And then you have to access tools and files using the browser. So normally nowadays we used to say if we have a computer and internet, that's enough to work in enterprise development. Right. Now let's look at our traditional ways of development, and we will look at web-based development versus traditional methods. So the traditional systems, we will have to use various hardware software environment, and this should be capable of some legacy systems. When I say legacy system, you know that when you look at, especially in developed countries, most of the financial applications were developed using a programming language called COBOL. Now, even though now we have AI and all these new programming languages comes in, still there are a lot of systems still working use the old software system. So when you have system like this, your old system, we call legacy system, should be compatible, right? So when we have now the internet-based systems, most of the time you will see the web as the platform, right? So many organizations, we use a web-based system, and then the applications are enterprise-wide. Enterprise-wide means for whole enterprise, we can have a system. If you compare both traditional systems and the web-based system, now traditional systems, when you want to scale up or down both, right? Usually we are interested in the up, let's say. That means when you want to expand your business, the organization, it's not easy when you're having a traditional system. You have to purchase additional, hardware, software, people, and so on. But with the software as a service model in place, now you are capable of requesting more information. And not only that, when you develop the application as a web application, right? So you can have a lot of benefits, right? Compared to a traditional environment. Right. Now let's look at some of the issues when you develop in traditional development. Now, especially when you design your system, you have to focus on compatibility issues. When you say compatibility issues, you have to always focus on what you already have. Now, that could be both hardware and software. So you might have some old hardware and software application, and also the applications, right? So you have to focus on that when you're using traditional development systems. And these systems usually run locally, right? Or maybe within company-wide networks. And they can use internet links, but these features, right, are what we call core element of the design. So because you are a web-based system development. Right. Now, when you want to develop, you can get three different paths. You can develop within the organization. We call it in-house development. You can purchase the software. And usually when you purchase software, so it might not, suits for your organization. So there could be changes that you need to perform. So you can use, you can purchase the software with some modifications. The third one, you can get some consultant from outside. So these are like three different parts of development. Now, in the traditional development, one of the issue is scalability. So your business may grow, right? Let's say we might get a lot of students, right? But then the problem is we have a limited space, we have a limited facilities. I mean, this could be an issue. But if you use web-based solution or software as a service solution, this won't be a problem, right? You can get. And another point is, like in traditional development, a lot of applications you have to use, you need a lot of computing power and the resources. But there's an advantage as well. Security issues are usually less complex, right? So because usually you have to maintain the network within the company network, not in the internet. Right, now let's look at web-based development. Now, when you look at web-based development, these systems can be developed using different frameworks. Example is .NET. Nowadays, we have Google App Engine or AWS Lambda. So these are the places that you can focus on. And the development will be internet-based development. And you use the web as a platform. And one of the positive aspects is easily scalable. You can increase number of users who can use our system, and you can run on multiple hardware environment because you have to pay only for what you use, right? Now, for example, when you want to a physical system in the premise, so you have to spend millions of dollars. Now, for example, server might cost about 6 million nowadays. And early it used to be about like 2 million. Things have gone up. So I think with all these crises and what has happened, right, the best would be, instead of purchasing by yourself, you can actually pay for the price or the portion that you use, right? And if we focus on large firms, they develop web-based systems as enterprise solutions, right? For example, customer relation management, order processing, and materials management. So when it comes to software-based development, usually they take it as a service, right? And when you have that kind of a model, you don't really worry about the computer power you have, the desktop computer power and resources. They are less dependent on us. Now, when you use web-based software, especially as a service, then you can limit in-house involvement, and you can have vendor to install, configure, maintain the system. So that will be more easier. The maintainability is not your problem. And web-based software, we have additional layers. You can say middleware, that's a spelling mistake, to communicate with existing software and legacy system. Right. Okay, now what we have Web 2, we normally call second generation, and they focus more on people for collaboration, interact, and share information. And based on continuously available use application, right? We can use regardless of number of users or how they access, modify, and exchange it. And basically what it offers is the interactive experience. We had wikis and blogs, social networking application like Twitter, LinkedIn, and Facebook. Right, now look at the cloud computing. So we can refer cloud computing can offer you online software, and then the data environment, you can have supercomputer technology, and then we have cloud computing. So that is the ultimate for software as a service, deliver services and data to users who would need it only an internet connection and a browser. So you can see it's easier now. You don't have to really focus on different hardware or purchasing servers, setting it up and maintaining. It won't be that easy. Right, some comparisons, things, what is happening, web version 1, version 2, version 3. So earlier we talked about basic web pages. Now we have social media. Even you can have semantic web, which can understand what you really meant. You can actually use any of this, and then you can actually compare. Right. Now, the previous one, what we discussed is actually development. The next one is outsourcing. So when I say outsource, mainly the focus is you are not going to develop by your own, but you are going to give it to somebody else. This could be the development, this could be even the maintenance, right? So two popular outsourcing options, we have application service providers, ASP, and firms of internet-based service, which call IBS. Then we have application service providers. Usually we have vendors, they deliver software application, or you can give access to an application. And how do you do that? You can actually request something. You can charge a usage or subscription fee. So ASP provides more than license, and it can rent operating packages to the customer. Then application service providers, usually they can provide commercially available software like databases or accounting packages. So if a company uses ASP to supply data management package, for example, company does not have to design, develop, and implement and maintain, you can use it. Some places you will see internet-based services. So these internet service-based providers provide powerful web-based supports for transactions, especially when you have order processing and then billing, customer relationship management. And here also their solution is attractive to the customer because it's offer online data center support. Third one, we talk about, second one, we talk about the in-house software development. Instead of outsourcing, we can develop your own system. You can purchase, you can customize, and then you can implement. So you have a lot of costs involved when you're making a decision. But you have to look at this cost, what we call the total cost of ownership. In short, we say TCU, right? And then companies can develop user interfaces. Then you can design then around commercial software packages. You can use Microsoft for improving individual productivity. Now, we were discussing so far what are the possible solutions we have when we want to develop a software. So let's look at what will happen during each of these phases. So we have choice. We start with the planning, analyzing, and then you take different parts. So you can say make and build, and last one you can talk about the so for example, planning and analysis, purchase, the commercial software packages, make, build, that means in-house system. So you can see there's an overlapping. That overlapped area is known as customized software. So here are some comparisons where you can understand exactly how these two are related. So reasons for in-house development, which means we are going to develop our own software. Reasons for purchasing software package. So by developing our own system that can address our own unique business requirements. Then you can minimize charges in business procedure policies, requires less time to implement, meet constraints of existing systems, proven reliability and performance benchmarks, meet constraint of existing system, require less technical development staff, develop internal resources. For example, future upgrades provided by the vendor. And the last one, we have satisfy unique security requirements, obtain input from other companies. So this is a bit of a comparison between what are the advantages you will get in-house compared to, purchased. Right. Let's look at the customize. If standard version software product does not satisfy company requirement, the firm can consider the adopting the package to meet its needs. There are three ways. What is the first one? You can purchase a book package, and then you can negotiate directly with software. Then you can purchase the package and make your own modifications. All these things could be possible. Right now, when you're talking about the amount of money you are going to spend, it's the money you are getting. So when you talk about the total cost of ownership, we have direct costs, which means acquisition cost. Now, for example, let's say you purchase a school management system. So initially you have to pay some money. This is called direct cost. Second one is after purchasing. That means you have paid in the beginning, but later there could be bugs, there could be some online issues, but we have make sure that everything is focused on ownership. Right. Okay. So when you say total cost of ownership, that means sometimes, I will have an example I will show you. What happens, sometimes what happens, now you purchase some software in the beginning, but later you need to make some changes, you need some money. So usually we will have indirect expense, and there could be other things like ongoing support or maintenance costs. Right. Now, let's focus on some financial tools. Now, these financial tools are very important, right? Before I go into details, I would like to ask a small question, right? So let me see. Let me share this. I'm going to stop for time being, and then we'll have a small poll. Right. Question is almost the same, but there's a slight change, right? So I have put up some value because I know the money depreciates. So if you need money today, I will give you 100, but I can give you 110 next year. The question is which one you are going to get it, right? So majority says today, I'm assuming that you are going to, invest on this somewhere, and then maybe you can collect more money by next year. And others might think, okay, we don't want to get any risk on getting money now. Maybe we are satisfied with it with 110, and we'll get it by next year. Right? Both are fine. But I think if you look at actually at least the fixed deposit rate right now, if you deposit 100 rupees, 100 rupees, you might get more than 110, right? If it is 15% of interest, you will get at least 150. Okay, one more question. Now, since this is also related to this, and I just want to think about this, about the finances. Now, let's say you deposit 1,000 rupees today, right? Let's say 10,000 in a fixed deposit account. Like fixed deposit rates are now usually about 15%, let's say. How much money you will get after 40 years time? Yes, you can use a chat session to give me your answer. The question is, so 3 financial analysis tools that we are going to discuss in this part are payback analysis, return on investment, and net present value analysis. So all 3 are actually quite powerful. And let's try to understand each of these methods. So in payback analysis, now when you're developing software, we are going to spend some costs, right? You are spending some money. And while you implement the system, you are getting some benefits. It'll improve the efficiency, it'll easier your work, right? You will get benefits. So we will compare the costs as well as benefits, and we will calculate how long it will take to match the cost that you have spent with the benefits that you are getting. So this period is known as payback analysis. Second one, return on investment. So we are going to compare the total costs and benefits, right? And with that, we calculate something called return on investment and how much you can get compared to how much you have actually spent on the project. Last one, we call net present value, NPV. Now we know that when you develop a software, initially you have to spend some money. And over the years also, you have to spend some money for maintenance, for example. Similarly, benefits will get added every year. So we will see the curve. And then, like the money that you are getting by, let's say, 1 year, how much it will be for the present year is what it matters, right? So we have to check the future value, how much it will worth for today's terms. So that is what we call net present value. So let's discuss each of these tools separately. Right. Okay. Before we go into details, we will discuss cost benefit analysis. When I say cost benefit analysis, what I meant here, usually you have to spend some money on developing software, and after development, when you implement the system, you will get some benefits. So there could be several stages. So you start first listing each development strategy. Then you identify all costs and benefits. Then think about the future growth. Think about the scalability. And when you are going to calculate the cost, you have to calculate the cost for both hardware and software. If you're actually going to purchase a software, then look for various licensing options, right? And then you use these financial tools. And then once you analyze your results using these financial tools, you can report to the management. Right. Now here are the steps of software acquisition process. So you start first evaluating system requirements, because we know any system, we have to find out what are our exact requirements are. Then you have to consider network and web related issues. Then you have to identify potential software vendors or outsourcing options. That means you need like what companies you are going to consider, what products you are going to consider. So you have to look at for details. After you identify these different software options, you need to evaluate them. We can call it as evaluate the alternatives. Then perform cost benefit analysis, which we will discuss later. Then you prepare recommendation, which software development strategy you are going to use, and then you implement the solution. Right. Now, during software acquisition, you have to request for proposal or request for quotation. The idea of request for proposal or request for quotation is like this. Now, let's say you need a software system. Let's say we want to automate everything in the university. But sometimes we really don't know what we need, because as users, we sometimes don't know our requirement. So what happened? We can actually openly request our vendors to make proposals. So they can create a proposal, they can evaluate, because they know better than us. We will tell them what exactly we are doing here, and they can come up with their own strategies, right? So using request for proposal, the vendors can respond, they can list all the system requirements, features, and they can bid for specific product or service. Let's look at the transition to system design. Now, system requirements document is we prepare as a deliverable in our very first phase, right? And here we will discuss about the constraints. We will recommend the best solution. We provide cost and time estimate for the development work. And this is the basis for our presentation, meaning like when you meet the management. So sometimes the company might decide, okay, let's develop in-house, which means you use whatever the existing staff members we have. We change the current system, or we change or we purchase some customized solution, right? And then we can stop all the further work. The next thing is we need to focus on different types of costs. So let's look at some cost classifications. When you look at different costs involved in project development or software development, we can classify them as tangible or intangible. We can say that it's direct or variable, and we can say that whether it's development or operational. So let's try to understand each of these in coming sessions. Tangible costs. So for example, when you have costs, if you can put up a number to it, we call it as a tangible cost. So salary, we know that everybody gets some salary, amount of pay. So that is a tangible cost. Let's say we have hardware and software. We have to spend some amount of money for that. Intangible costs, sometimes we cannot calculate some cost very easily. Now, how do you, for example, how do you calculate the customer satisfaction, right? How do you know whether our customers are satisfied or not? Right. So when you want, if you're trying to calculate that, it's very difficult to put you a number to it. Sometimes we can ask them to rate from 1 to 10, but it's very difficult to put up a number. So these things we know as tangible costs. Next set of costs. We can talk about direct costs. We can talk about indirect costs. Direct and indirect. Now, direct cost means salaries, hardware, they are direct costs. Indirect costs, right? Sometimes we have to spend money, not only the development, for the others. For example, salaries for the development staff, development members, let's say salaries for the software engineers, it's a direct cost. But salaries for, let's say, administrators, let's say network administrator, it will be indirect cost because it's not directly related to our software development. Right? Insurance expenses, in case they're not directly related to our development costs, so we call indirect costs. Then we have fixed cost and variable costs, right? So for example, if you say salaries, we can say fixed costs, right? So for example, telephone charges, it's variable, right? So the cost can be divided as fixed cost and the variable costs. Then we can also divide as development and operational. So development, usually we say it happens only once, right? When the system is developed. Operational cost means once your system implemented, and when you're using the system, we call operational cost, maintenance costs. Okay, although we try to categorize these, right? The pure classification is not possible. So we can say some costs, they can belong to more than one category. So we can say overtime pay, usually when somebody works after hours, let's say after 4 p.m., they'll get what we call extra amount of money for the overtime payment as an overtime payment, right? So when you say overtime payment, it could be development cost, right? Because it's directly relevant to the development. And it's variable. We don't know because it depends on the number of hours you work extra. And it's a direct cost because it's directly related to our project. So likewise, let's take another example. Let's take website fee, right? So when you say maintenance fee for a website, it's operational, right? It's fixed and it's indirect. It's not directly related to our software. So there could be like different categories like that. So far we discussed about the cost calculations. The most difficult part would be like benefit calculation sometimes, because you might not get dollar amount or a numerical value for this. So benefit also we can classify as tangible, intangible. And fixed or variable, and it could also be direct or indirect, right? And sometimes you can also classify it as positive benefit or cost avoidance benefit. We'll come to that later on with example. Right, now more details about the positive and cost avoidance benefit. Positive benefit meaning it will increase the revenue, meaning the profit. It will improve the service. It will contribute to the organization, right? So for example, improved information availability, greater flexibility, faster service, higher employee morale, better inventory management. These are like positive benefits. Cost avoidance benefits, that would be necessary if new system were not installed. So for example, handling the work with the current staff. Otherwise, you have to hire additional people. You're not having replace existing hardware or software, right? Otherwise, you have to face a problem with the current system. Okay, now let's look at the analysis part. So the first one we are going to discuss is cost-benefit analysis. So in cost-benefit analysis, we compare the costs as well as benefits. So this cost-benefit analysis we can perform using our system development life cycle. So this could also be used to determine the economic feasibility, right? So one of the things that we do in the beginning before actually development, whether the system is economically feasible, the amount of money that you have to spend, whether you have it right now. Right. There are many cost benefit analysis, which we are going to discuss now. Payback analysis, return on investment, and present value analysis. Right. Now, let me start our first one. And this is what I'm going to discuss today. And then the other two I will discuss in the next week class. And based on that, you are going to work on a small group work, right? So please try to understand the theoretical part that I'm trying to explain it here. Okay, now payback analysis, our first financial analysis tool that we are going to discuss. Here is how we are going to perform payback analysis. So what is payback analysis? So with the payback analysis, we can determine how long it will take to pay the costs that you spend on the development, right? So in other words, we can say the time it takes to recover the system costs. So here are the steps. First one, we need to determine the initial development costs. Second one, we have to estimate the annual benefits. Then we have to determine annual operating costs. Then we can find the payback period, right? With the benefits accumulated by the system. Right. Let's try to understand the cost and benefit and how it varies over the time. Now, in this figure, you can see in horizontal axis, we have a timeline. Vertical axis, we have cost in dollars. And these dashed lines indicate our system development time. So this duration is system development. And this duration is system operation. And maybe after some time, you might discard this. So according to this, what you can see, the cost will be really high in the beginning. Initially, it will be very high. You spend quite a lot of time on this. Then after that, what happens? The cost will be reduced. And after some time, it will be consistent. So that means you are going to use the system, you will be familiar. But after some time, the cost will be again increased, because when things are getting old, you will get again a lot of issues. So usually costs, spent on the development will look like this. Initially, you have to spend a lot of money, then keep on reducing, and then it will be a stable. Then after some time, it will keep on increasing. That's how the costs are involved in development. Second one, benefits. A benefit means once you develop the system and when you implement, you are going to get some advantages, right? You will finish early, right? So, and system will be efficient. So the benefits, usually there will not be any benefits during the system development. Usually it will start after the system development and keep on increasing. And this is how the curve will look like. Right. Now, if I combine both curves together, so this curve will be the costs. Initially, the costs are high, then it comes to a fixed value and then keep on increasing. If you look at the benefits, on the other hand, you can see it will keep on increasing. Now, when you calculate the total cost, so when you say total cost, that means, right, cost will be, right, let's say costs. Let me put up a different color. So the cost will be this area. This is the cost curve. right? That is the cost, the amount of money you spend on the development, the costs. And the next one is benefits. So benefit starts here, right? Benefit starts. So this area, when the area matches, that means the amount of money you spend, you get it as a benefit. That period is known as payback period. This is known as payback period. So what is payback? The amount of money you spend on development of the system, when it is equal to amount of benefits you are getting from the system, that period is known as payback period. Right. Let's do a small exercise, right? So I will give you like two projects. We have project A and project B. And then let me print the screen and let me give you. So I will put up in the WhatsApp group so that you have this with you. You can perform the calculation. Right. So what you see here is two projects. And the decision that we want to make is which one you are going to recommend as a system analysis. Are you going to recommend project A or are you going to recommend project B? Right. Now let me explain this. So let's look at the project A first. So we have years and we have cost and benefits. So for example, initially in project A, we need like 60,000. And as a benefit, we are getting 3,000. First year, right? Then the cost will be 17,000. Benefit will be 28,000. Year 2, cost will be 18,500. So we have 60 in the beginning. Then next year, 17,000. Next year, 18,500, 19,200. It goes on like this. Benefits. First year, you will get 3,000, then 28,000, 31,000, 34,000, and so on. Now, what is payback analysis? What is payback analysis? In payback analysis, you look at the total cost, which we call cumulative cost. So if you look at the third column and fifth column, we have cumulative cost and cumulative benefits. Now, to calculate the payback period, we have to match those two costs and benefits together. I have a small question. When you will see the cost matches the benefits, how many years you have to spend on that? right? How many years do you think it will take for the project A to get payback period? In other words, when do you think the cumulative cost matches with the cumulative benefits? Yes, when you think cumulative cost meet with cumulative benefits. Yes, any ideas? Yes, Shashank said year 4. Let's calculate, see, year 4, yes, we have 135,700, that is the costs. Benefits is a little less, 132,000. So it's very close to 4 years. I think little more than 4 years. True, that's good. What about project B then? How many years the project will take to meet the payback analysis? Right, Hansel said 5 years. Yes, almost okay. Project B, if you look at 4th year, the cost will be 191,000, and then the benefit would be 156,000. 5th year, it's about 217,500. The benefit will be 230,000. So again, it's between 4 and 5, but I think more towards the year number 5. So what you should do now is a small exercise I want you to do using Excel. So you have given all the cost and benefits. Use Excel to perform this. Type all the cost and benefits for each of these projects, project A and project B. You can draw the line for costs. You have to draw the line for benefits. When the two line meets, you know that's the payback period, right? So something similar to this, right? I want you to try you separately as a group, right? I'll put you in group for a few minutes time. So as a group, use Excel to draw a small figure where the cost and benefit line meets, and see whether you can find exact answer. So you can see here, right? Project A, the payback period means almost is 4 years. But project B, it's about half of 4th and 5th years. Right. I think that's all what I have for today. And now I'm going to put you in groups. Spend some time on this. I will give you 1 week to finish, but I think you can finish within a couple of minutes time, right? It won't take much time if you get together. So we have about 88 today.